In this video, we will try to do a simple numerical which gives you an understanding that the reference frame or the reference point does not affect the center of mass of a system. In order to show that, I took two masses. One is of 10 kg and another one is of 20 kg. These two are separated by 2 meter distance. Now, I just want to select one point of reference. So if I select the point of reference, let me write if the point of reference is A, let us suppose, then how can we find the position of center of mass? We know that the center of mass is given by xcm. Okay, so is equal to m1 into x1 plus m2 into x2 by m1 plus m2. So where here x1 comma x2 are the distances from reference point. Here I selected the reference point as A. Therefore, what is x1 value? X1 value becomes 0 and x2 becomes 2 meters. Let me find the center of mass of this two particle system or two mass system. M1 is 10 kg, so 10 into 0 plus M2 is 20 kg, so 20 into 2 by M1 plus M2, which is 10 plus 20. It gives us 20 into 2, 40 by 30. So it is 4 by 3 meters from the reference point. So the center of mass we got here is 4 by 3 units from the origin or from the reference point. Now I am taking one more reference point. Let me consider the reference point as B. Okay, so point of reference I am considering as B, and here I am considering the origin. Okay, so to the left side of origin all the distances are negative. To the right side of the origin all the distances are positive. This is the convention that we generally follow. Therefore, xcm is equal to m1 mass is at a distance of 2 meters to the left of point B. Therefore, 10 into you will get minus 2 plus, and B itself is the reference point. Therefore, the distance x2 becomes 0. So 20 into 0 divides 10 plus 20, which is m1 plus m2. Now it gives us minus 20 by 30. So 0 0 cancels out. It is minus 2 by 3. What is minus indicates? Minus indicates the center of mass. Minus implies the center of mass lies on the left side of a origin, left side of reference point or origin. Okay, and if you observe the value 2 by 3, so from B if you move 2 by 3 units towards left, you got this point only. So previously we got 4 by 3 and we got this point as the center of mass. Now we got minus 2 by 3, so we got the same point. Okay, I changed the reference point from A to B. Even though the reference point is changed, the center of mass position is not changed. Okay, so let me select one more reference point, which is exactly at the midway between two masses. Okay, so let me give the point name for that. So this is 3 by 3, which is equal to 1. So I am giving that point as name as C. Okay, now what is the point of reference? So point of reference is equal to C. Okay, Now, point of reference is at origin. Generally, we consider it as origin. The rightward distances are considered as positive, and the leftward distances are considered as negative. Okay. Now, m1 is 10, so 10 into what is the distance from C to A? It is exactly at the midway between A and B. That's why the distance from C to A is 1 meter, and it is on the left side of C, therefore it is minus 1. Plus, I'm taking the distance to B from the reference point, and it is on the right side, and the distance is 1 meter, so plus 1 you will get. So 20 plus 1. Okay. Whole divide with 10 plus 20. Now 10 into minus 1 is minus 10. 20 into plus 1 is 20 by 30. And it is equal to 20 plus 10 is 20 minus 10 is 10. 10 over 30, zeros cancels out. You will have 1 by 3. So what does it indicates? It indicates it is a plus 1 by 3. Plus means towards right from the reference point. So reference point here now is C. So if you take 1 by 3 distance from the reference point, you reach the same point. Okay. So from all these three different simple problems, what we can understand is the reference point, the center of mass position, is not changed according based on the selection of your point of reference or axis of reference. Whatever may be the axis of reference, the center of mass position will be same. In this case, it is at 4 by 3, or it is at a distance of 1.33 meters from A. One more thing which we can conclude from this problem is the center of mass is, if you observe here, it is closer to 20 kg. It is far away from 10 kg. Why? Because 1.33 is not exactly at the midpoint. It is somewhere near to mass B. Therefore, from this what we can conclude is the center of mass always lies near to heavier mass. Okay, in this case, out of 10 kg and 20 kg, 20 kg is heavier mass. Therefore, the center of mass lies near to 20 kg.